Good morning, my dear friends. Myself, Pratha Gaurang. I am student. I have done Master of Engineering in Electronics and Communication, and my research area is wireless sensor network. Today's topic is to extend life of wireless sensor network. This is the basic overview in which we can do the work in research area in wireless sensor network. Today's presentation outline. First of all, introduction, in which we give the basics about wireless sensor network, architecture, node, and likewise other things. Problem statements. What is the main problem as a point of view electronics engineer in wireless sensor network? And the solution of that problem by there are several methods are given in conclusion and references. First of all, wireless sensor network introduction. It is an emerging technology made up of small wireless nodes which are smart enough to communicate effectively with nearby other sensor nodes and send data to sync. Means it's a technology. This is the basic diagram or architecture of sensor network. In this sensor field is there. In sensor field, nodes are deployed and nodes sense data and nodes are what do they sense data and data is that data will be sent to the sync. Sync is connected to our system or internet or satellite or any type. So data are given to sync, in sync further give pass away to the internet or satellite or any processing unit. So node in sensor network, nodes are deployed and they sense data and that data are sent to the sync. This is the basic about very few basics about sensor network. This is a node architecture. This is the general hardware architecture of node. In node there are main four parts are there and with memory. Communication device means radio transceiver, transmitter or receiver, controller, microcontroller, and sensor and actuator. So sensor sense data and that data do microprocessor or controller process on that data and transmitter receiver send data and receive data from other nodes. And this communication device control and sensor are supplied by power supply. So most probably microcontroller will be at in mica node 8 megas microcontroller will be used. In communication range frequency is around 2 to 2.4 gigahertz in mica nodes, and sensors are it depends on application. If we can it depends on application, and flash memory is used which will store the program, and power supply is most probably to a cell. This is a simple figure of mica 2 node. In we can see it is a very small node, mica 2. This node is most probably used for environment monitoring, temperature, humidity, and etc. In this black part is used for the battery to ASL 4 to ASL used in this place in in black part. Microprocessor 8 mega 128L and memory and other things are there. Energy consumption of node. So most probably this sensor node are battery operated and once the battery is out drained total drown, then it node is no more use. So battery lifetime battery is very important in sensor network. So energy consumption of node is in first of sensing unit, microprocessor and transistor as we have seen. Sensing unit for passive light or temperature sensor, the power consumption can be very small. So we can neglect this sensing unit energy consumption most probably, which is because this is a application dedicated. So it's not enough most probably research to as a sensoring. Mostly in passive sensor means no power supply is used, only A to D converter use this power. So which is very small. Second is microprocessor or controller. I refer many books or data sheets. In that most probably they are around 1 nanojoule used for one instruction. So it's not too much we can say. And third one is a transceiver. To send one bit around 100 nanojoule used for to transmit one bit. So most of the energy consumed in transceiver. Let's this is a figure for mica 2, mica Z node. So we can see that sensor is very less, consumption of energy for sensor is very less, controller is bigger than that, and transceiver part consumes more energy. So in figure we can see transmitter, receiver, idle and sleep. These are the modes of transceiver, and that consumes more energy. So energy of node can be increased by decreasing the energy consumption of radio. So radio communication, if radio communication we decrease, then lifetime of node can be increased. So energy consumed by transceiver is more compared to the other component of nodes. Network life. Network lifetime is how time duration before certain percentage of node dies. In general, most of the paper, IEEE paper or researcher, most of the give this kind of definition in their paper. Lifetime defines the time duration required to die first node sensor node. So suppose we have 100 sensor nodes in sensor fields. So first node time duration, time required for first node to die is taken as a lifetime of network. It is not necessary to keep this first node die. If in some application 10 node first 10 node die consider, or other thing is the application point of view. So lifetime of network defined by the life of node. So node dies, that's why we can say the lifetime of network is defined by the node. So if we increase the lifetime of node, we can save the increase the life of sensor network, and we can save increase lifetime of node by decreasing radio communication, because radio communication consumes most of the energy in sensor of node. A solution of lifetime enhancement, efficient node deployment. So arrange node in such a way that routing reduce and area coverage is maximized and less number of nodes we require. So efficient node deployment. Second one is scheduling. It consider application by temperature sensing application. So temperature does never change abruptly. It changed gradually. Suppose right now 25 degrees, then after 25.2, 25.3, 26, or that's why increasing. Not directly 25 to direct 30. So scheduling means send data and send data to base station such that in a proper ways. Not every 1 minute we sense temperature and send data. So we sense temperature right now, then after around 1 hour or 3 hours. So that temperature change in temperature is very not too small. So this is defined by the scheduling. Data aggregation. Data aggregation, routing and mobile sync. We further discuss this. The area of interest of mine is energy efficient node deployment, such that hop required in routing reduced so as radio communication will be reduced. So deployment by deployment we reduce the routing, and node deployment such that area coverage maximum and number of nodes requirement reduce. So if we reduce the number of nodes, then we can also increase the lifetime of network. Data aggregation. Instead of sending all data, we can send very few data to sync, so and maintain the quality of data. Then also we, due to less number of data sent to the base station, less number of radio communication occur, and we can increase the lifetime of network. Mobile sync provides. Mobile sync means if sync is movable, then we move the mobile base station in such a way that routing is reduced and energy consumption of all node is same. So balanced energy consumption we can say, and this balanced energy consumption all node die at the same time. So increase this way we can increase the lifetime of network. Conclusion. Lifetime of network is defined by energy node, as I have said earlier. Now most of energy consumption, we have seen that most of the energy consumption is done by the transceiver unit. And by reducing radio communication and making energy consumption balance energy consumption of all nodes, we can increase the lifetime of sensor network very good. These are references. Thanking you. Any query then contact me at rathagaurang@hotmail.com.